So we're going to go through this data collection together. I'll be doing the simulation of the model for you, and you'll be able to use my values to record for the number of toothpicks broken as we kind of go through. And we'll do a couple of these together, but you'll need to kind of do the counting and data inclusion in this on your own, as I'm not going to do that for the entire video. So to kind of illustrate and explain what's going to happen to get our data and what's going on, I have toothpicks in a bowl. There's 100 toothpicks in this bowl. The bowl is going to represent a cell. The toothpicks are going to represent the amount of a substrate in a cell. And keep in mind, substrates can determine concentration. All right, so in this case, the concentration is going to be relatively high compared to the second video you watch over this. Now keep in mind, what breaks apart a substrate is an enzyme. So in this case, my hands are going to represent an enzyme. So what an enzyme can do is it can break apart a substrate into products. An enzyme, however, cannot break a product in half again. So once a toothpick or a substrate is broken, that's it. This enzyme cannot act on it any further, but it can act on the unbroken ones. Another thing to consider is this is all in reality, it's happening inside the cells of our body. So when a substrate is broken, it has to stay inside the cell. It cannot leave it. So what we're going to be measuring is really how quickly can I break these toothpicks per second over the course of a total of 3 minutes, which is what this data table would add up to. Looks like we have 1, 2, 3, 4. Looks like we have 6 trials. The first 3 will last 10 seconds, the fourth one 30 seconds, and then the last 2 60 seconds. Total of 3 minutes. So let's see how quickly I can act as an enzyme to break apart these substrates. While I'm doing this, you won't be able to see, you'll just have to kind of take my word on it, that I am closing my eyes because substrates do not have eyes, or enzymes do not have eyes, so I can really turn my head and I'll be actually watching my timer off to the side without looking to ensure integrity of the data. So the first trial is 10 seconds, and on my mark, on my set, go. 1, 2, 3, 4. I broke 4 in 10 seconds. So what you'll need to do is record that number right here. I broke 4 in 10 seconds. What was my reaction rate? Well, I was breaking 4 in 10 seconds, and I gave you the equation up here. I have to divide the number broken by the total time of that trial. And the time of that trial was 10 seconds. So 4 divided by 10 is 0.4. And what that tells me for the rate, it tells me that my rate was I was breaking 0.4 toothpicks every single second. And what we're going to measure is how does this rate change over the course of time. Keep in mind, as we kind of proceed, I now have to work around and through some of these broken toothpicks. There will be times when I pick up a broken toothpick, but I can't break it down any further. Furthermore, between each trial, I should probably give this bowl a shuffle because in reality, all of these would be suspended in a solution, in a fluid, so they're constantly moving around. So let's do our second trial, 10 seconds again. And on my mark, on my set, go. 1, 2, 3, 4, 5. Broke 5. So you can go again to our data table, 5. The rate would be 5 divided by 10 seconds, not 20, 10 seconds. So 0.5 is my rate. So my rate got a little bit faster. We're going to go another 10 seconds. And at this point, I'm no longer really going to be coming back to this table. you'll need to just kind of follow along with the video and fill in your information and calculate the reaction rates on your own. I'll still do the counting for you though. So the next one is 10 seconds. Let me set my timer. And on my mark, on my set, go. 1, 2, 3, 4. I got 4. So third trial, 4. The next one, I believe, is 30 seconds. Feel free to pause the video if you need to record any data. So 30-second trial, here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I got 13. I picked up a couple broken ones already, so that definitely slowed me down a little bit because that happened. Now I got 2 more trials, 60 seconds apiece. On my mark, get set, go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 25. I got 25 on that time. Now what we have to consider is how many unbroken toothpicks are left. I started with 100, so the concentration was relatively high, but I would assume it's going to start to become a little bit harder to find unbroken toothpicks. So I might expect my reaction rate to slow down a little bit here. Maybe not, we'll see. All right, last trial. On my mark, on my set, go. Broken, broken, broken. 1, 2, 3, 4, 5, 6, 7, 8, 9, I only got 9 that time. I kept finding broken ones. Yet there's still a few unbroken ones in here. I just was unable to find them because now the saturation of all the broken substrates, all the products, kind of make it difficult to kind of sift through. And that's kind of what happens in our cells. With a decreasing amount of substrate and an increasing amount of product, it becomes harder for the enzymes to actually locate and find substrates to continue the breakdown. So go ahead, record that data, and you can then continue on to the second video of the time trials.